Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome to our video presentation. This project was created for the English for Chemistry courses with the theme Higher Order Thinking Test Instrument on Reaction Rate Material. We secondly thanks our lecturers, Sir Dr. Kriswantoro, M.Pd, and Mrs. Isra Miharti, S.Si, M.Pd for their support and guidance. Now, let's introduce the members of Group 1. First, Widia Silvani Putri with student ID number 001. Second, Ayu Wiranti with student ID number 007. Third, Serliana Simanjuntak with student ID number 55. And lastly, Nurul Sartika with student ID number 16. Each of us will present 5 questions along with explanation. Let's begin with the first speaker.
Hello everyone, I am Widia and I'll be explaining question 1 to 5 of our reaction rate problems. Let's start with question 1. This question is about the effect of temperature on the rate of dissolution. Explain it using collision theory. It starts with a short story. Anissa used hot water while Gilang used cold water to dissolve sugar. Anissa thinks the sugar dissolves faster because of higher temperature. They want to test it scientifically. Main question, design a simple experiment to prove that temperature affect the dissolution rate of sugar based on solution theory. Okay, let's discuss the answer. Or first, to be determined experiment title. Experiment title is effect of temperature on sugar dissolution rate based on solution theory. From the title, we can determine the objective. The objective is proving that an increases in water temperature accelerates the rate of sugar dissolution in accordance with the principles of solution theory. Don't forget to specify the hypothesis. Hypothesis is if the water temperature is higher, the sugar will dissolve faster because the kinetic energy of water molecules increases, so the solutions between water on sugar particles become more frequent and more effective, which accelerates the dissolution process. Also, create tools, materials, and experiment steps such as for tools and material there are to clear glass cup, 150 ml of water at 30 and 70 degrees Celsius, 2 teaspoons of fine sugar, a thermometer, and a stopwatch. From the design, then the relation with the collision theory is, according to collision theory, dissolving occurs when particles collide effectively with enough energy and proper orientation. When sugar is added to water, water molecules collide with sugar particles on the surface. Heating the water increases the kinetic energy of water molecules, causing them to move faster and colliding more often and more forcefully. This leads to more effective collisions, making the sugar dissolve faster. Therefore, sugar dissolves faster in hot water not because of the glass color or sugar brand, but because higher temperature increases kinetic energy and the rate of effective collisions. Okay, now moving on to question 2. This question about why a combustion reaction doesn't occur even though the gas mixture is in the correct stoichiometry ratio. The experiment is done at 27 degrees Celsius without extra heat. Main question, according to collision theory, explain why the reaction doesn't happen even when the number of gas particles is enough. Let's now discuss. The question given 1 methanol gas and oxygen are mixed in stoichiometry ratio. 2. The reaction doesn't occur spontaneously. 3. Room temperature is 27 degrees Celsius. 4. No heater is used and the last ventilation is open. The question is, what is the main reason why the reaction doesn't occur according to collision theory, and why does the reaction remain slow even though the concentration is sufficient? And the answer, according to collision theory, chemical reaction only occur if 1. Particles collide, 2. With the correct orientation, and the last have sufficient. So, that means is, according to collision theory, the reaction between methane and oxygen doesn't occur at room temperature 27 degrees Celsius because the particle lack sufficient kinetic energy. Although the gases are in the correct ratio and pressure increases collisions, most are ineffective without enough energy to overcome to activation energy. External factors like dim lighting or ventilation are irrelevant. The main reason the reaction fails is the low temperature, which limits particle energy and prevents effective collision. Next is question 3. The question about using collision theory prove how many times the reaction rate increases when the temperature goes from 300 Kelvin to 320 Kelvin. Let's now discuss how temperature affects the reaction rate using the Arrhenius equation. We are given one activation energy, EA, equal 80 kJ per mole or 80,000 joule per mole. 2. The gas constant are equal 88.314 joule per mole Kelvin. Temperature 1 is 300 Kelvin and temperature 2 is 320 Kelvin. To solve this, we use the Arrhenius equation to find the ratio of the rate constants. Learn K2 over K1 equal EA divided by R times open parenthesis 1 over temperature 1 minus 1 over temperature 2 closes parenthesis. Now we substitute to value. Learn K2 over K1 equal 80,000 divided by 8.314. multiplied by open parenthesis 1 over their 100 minus 1 over 320 close parenthesis. This becomes ln K2 over K1 equal 9623.35 times 0.000283. Then ln K2 over K1 equal to 0.004. Now we calculate K2 over K1 equal e to the power of 2.004, and that gives us K2 over K1 equals 7.42. Then we have question 4. This question is based on a reaction rate table with change in partial pressure. The reaction is nitrogen gas plus 3 hydrogen gas gives ammonia gas. Main question, what is the relative reaction rate when the pressure of N2 is 200 atmosphere and H2 is 50 atmosphere? Now let's discuss. This question is about the effect of partial pressure on the reaction rate. The reaction is nitrogen gas plus 3 hydrogen gas gives ammonia gas. The question is what is the value of X? Let's solve this using 3 steps. Step 1, compare that 1 and 2. Here nitrogen pressure is the same 200 atmosphere. Hydrogen pressure goes from 200 to 100, which is a half. The reaction rate also goes from 1.0 to 0.5, which is also half. So the order of hydrogen is 1. Step 2, compare that 1 and 3. Now hydrogen pressure is constant at 200, but nitrogen pressure drops from 200 to 100, which is also half. The rate drops from 1.0 to 0.25, which is 1/4. Since 1/4 is 1/2 square, the order of nitrogen is 2. Step 3, use the rate law. We now use the rate law formula. V equals K times concentration of N2 square times concentration of H2. Let's use that from the first row. N2 equal to 100, H2 equal to 100, rate equal 1.0. Now look at that 4. N2 equals still 200, X2 equal 50. So hydrogen drops from 200 to 50, which is 1/4. Since the order of H2 is 1, the rate also drops 1/4. So V sub 4 equals 1.0 times 50 divided by 200. Final answer is X equals 0.25. And finally, question 5 is question is about how temperature change affect the rate of a reaction. It says that every 10 degrees Celsius increase doubles the rate. Given reaction rate at 65 degrees Celsius is 0.6 molar per second. To use X to find the rate at 25 degrees Celsius. Main question, use the pattern to calculate the reaction rate at 25 degrees Celsius. We are given that every increases of 10 degrees Celsius cause the reaction rate to double. Delta V increases by a factor of 2 for every 10 degrees Celsius rise in temperature. We are also given 1 temperature 1 equals 65 degrees Celsius, 2 and the rate at this temperature is V1 equals 0.6 molar per second. The question is, if the temperature is decreased to T2 equal 25 degrees Celsius. Now let's discuss this answer. First, we calculate the temperature difference. Delta T equals T2 minus T1 equal 25 minus 55 equals minus 40 degrees Celsius. That means V2 equal V1 times delta V to the power of delta T per temperature. V2 equals 0.6 times 1 over 2 to the power of 4. Let's calculate it. 2 to the power of 4 is 16, so we get V2 equals 0.6 divided by 16. That is 0.0375 molar per second. That means the new reaction rate is 0.0375 molar per second. That's all for me. Now I'll pass it to Ayu, who will continue with the next 5 questions.
Hello everyone, I am Ayu, and I will be explaining question 6 to 10. Let's begin with question 6. Question 6. Can be seen the question above. A chemical reaction has a reaction rate that is influenced by the concentration of reactant A. Pay attention and understand the question. Determine the value of the reaction order for reactant A. Let's discuss the solution to this problem. Discussion. Given initial reaction rate equal to K concentration of A times R. Concentration of A is 0.5. Reaction rate after the concentration of A is increased equal to K. Concentration of A is 1. The reaction rate increased fall at a temperature of 300 Kelvin. R equal 8.314 joule per mole Kelvin. Ask, what is the value of the reaction order for reactant A? Next, answer. Suppose the initial reaction rate equal to R1 and the reaction rate after the concentration of A is increased equal to R2. R1 equal to K 0.5 rein in. R2 equal to K 1 rein in. It is now that R2 equal for R1 then K 1 rank N equal for K 0.5 rank N. Then 1 per 0.5 rank N equal to 4. 2 rank N equal to 4. 2 rank N equal to the power of 2 and equal to. So the reaction order with the reactant A is 2. Next, question number 7. Can be seen the question above. A reaction will occur 3 times faster than before for every 20 degrees Celsius. If at a temperature of 50 degrees Celsius, a reaction takes place for 3 minutes. Identify how long the reaction time is required if at a temperature of 70 degrees Celsius. Discussion. And now, reaction time at 30 degrees Celsius equal to 3 minutes. The reaction rate increases 3-fold for every 20 degrees Celsius. New temperature equals 70 degrees Celsius. Ask, what is the reaction time at 70 degrees Celsius? Solution. V equal to 1 per T. Become T equal to 1 per V. T equal 1 per 3 rank N. N equal to multiple of temperature increase 20 degrees Celsius. T equal to 70 degrees Celsius. Become N equal to T 0 equal to 30 degrees Celsius. Become N equal to 0. T equal to 1 per 3 rank N times 3 minutes. Equal to 1 per 3 rank 2 times 3 minutes. 1 per 9 times 3 minutes. 1 per 3 times 3 minutes. So, the reaction time at 70 degrees Celsius is 1 per 3 times 3 minutes. Moving on to question number 8. Methane gas CS4 is reaction with bromine gas Br2 in a closed reaction that takes place at a constant temperature. Following the reaction, methane plus bromine produce CS2Br2 plus 2SBr. And the concentration of Br2 gas increase at a rate of 4 m per second Rn-1. Determine the rate of formation of CS2Br2 in unit of m second Rn-1. Discussion. And now, reaction, methane plus bromine produce CS2Br2 plus 2SBr. Reaction rate Br2 equal to 4 m per second Rn-1. Ask, CS2Br2 formation rate. Answer, based on the coefficient comparison 2 to 1. Then, reaction rate CS2Br2 equal to 1 per 2 times VBr2 equal 1 per 2 times 4 equal to m per second Rn-1. Now, we have question number 9. A rate determination experiment for 2 chemical reaction give the following date. Reaction 1, C produce D. Reaction 2, M produce N. The rate of a reaction 1 become 1 per 4 times the initial rate. Meanwhile, in reaction 2, the rate of reaction 2 become 3 times the initial. However, under certain condition it is known that the concentration of C is to which the concentration of M concentration C equal to concentration M. From this information, so the conclusion and explain your conclusion and the comparison. Discussion. And now, reaction 1. If C become 1 per 2 time, the rate become 1 per 4 V. 2 order reaction to C. So, reaction rate C equal to K concentration C Rn2. Reaction 2. If concentration M become 3 times the rate become 3 V. 1 order reaction to M. So, reaction rate M equal to K concentration M. The rate constant K is the sum for both reaction. Given concentration C equal to concentration M. Ask, compare the rate of reaction 1 and reaction 2. So, the calculation and explain the conclusion. Answer. Use the rate formula for each reaction. Reaction rate 1. Reaction rate C equal to K concentration C Rn2 equal to K2 concentration M Rn2 equal to K times 4 concentration M Rn2. Reaction rate 2. Reaction rate M equal to K concentration M. Compare the two. Reaction rate C per reaction rate M equal to 4K concentration Rn2 per K concentration M equal to 4 concentration M. Then, reaction rate C equal to 4 concentration M times reaction rate M. Since concentration M is a positive value, the rate of reaction 1 is 4 times faster than reaction 2 under this condition. Conclusion. If the concentration of C is twice the concentration of M, then the rate of reaction 1 is 4 times faster the rate of reaction 2. And finally, question number 10. Can be seen the question above. Pay attention and understand the question. Reaction 4NH3 react with 5O2 product 4NO plus 6H2O. The reaction rate of ammonia is 0.24 m per second. The reaction rate of oxygen in the reaction equation. Discussion. And now, reaction 4NH3 react with 5O2 product 4NO plus 6H2O. Reaction rate of ammonia is 0.24 m per second. Ask. Reaction rate of oxygen. Answer. Reaction rate oxygen equal to 5 per 4 times reaction rate NH3 equal to 5 per 4 times 0.24 equal to 0.3 m per second. So, reaction rate oxygen is 0.3 m per second. That concludes my part. I'll now hand it over to Serliana, who will present the next 5 questions.
Hello everyone, I am Serliana Simanjuntak and I will explain question number 11 to number 15. Hello everyone, I am Serliana Simanjuntak. Question number 11. At room temperature around 25 degrees Celsius in an open laboratory without humidity control, the following reaction was carried out. 2A plus B produces 3C. The following data was obtained from the experiment. If the concentration of A is double while the concentration of B remains constant, the reaction rate increases fourfold. If the concentration of A and B are triple, the reaction rate increases 27-fold. The product format in a colorless or odorless is easily identified. If the value of the reaction rate constant is 4 times 10 raised minus 5, determine the reaction rate when the concentration of A is 0.2 m and the concentration of B is 0.1 m. Question number 11. At room temperature around 25 degrees Celsius in an open laboratory without humidity control, the following reaction was carried out. 2A plus B produces 3C. The following data was obtained from the experiment. If the concentration of A is double while the concentration of B remains constant, the reaction rate increases fourfold. If the concentration of A and B are triple, the reaction rate increases 27-fold. The product format in a colorless or odorless is easily identified. If the value of the reaction rate constant is 4 times 10 raised minus 5, determine the reaction rate when the concentration of A is 0.2 m and the concentration of B is 0.1 m. Question number 11. At room temperature around 25 degrees Celsius in an open laboratory without humidity control, the following reaction was carried out. 2A plus B produces 3C. The following data was obtained from the experiment. If the concentration of A is double while the concentration of B remains constant, the reaction rate increases fourfold. If the concentration of A and B are triple, the reaction rate increases 27-fold. The product format in a colorless or odorless is easily identified. If the value of the reaction rate constant is 4 times 10 raised minus 5, determine the reaction rate when the concentration of A is 0.2 m and the concentration of B is 0.1 m. Question number 11. At room temperature around 25 degrees Celsius in an open laboratory without humidity control, the following reaction was carried out. 2A plus B produces 3C. The following data was obtained from the experiment. If the concentration of A is double while the concentration of B remains constant, the reaction rate increases fourfold. If the concentration of A and B are triple, the reaction rate increases 27-fold. The product format in a colorless or odorless is easily identified. If the value of the reaction rate constant is 4 times 10 Range -5 determine the reaction rate when the concentration of A is 0.2 m and the concentration of B is 0.1 m. Question number 11. At room temperature around 25 degrees Celsius in an open laboratory without humidity control, the following reaction was carried out. 2A plus B produces 3C. The following data was obtained from the experiment. If the concentration of A is double while the concentration of B remains constant, the reaction rate increases fourfold. If the concentration of A and B are triple, the reaction rate increases 27-fold. The dot format in a colorless or odorless is easily identified. If the value of the reaction rate constant is 4 times 10 range -5 determine the reaction rate when the concentration of A is 0.2 m and the concentration of B is 0.1 m. Question number 11. At room temperature around 25 degrees Celsius in an open laboratory without humidity control, the following reaction was carried out. 2A plus B produces 3C. The following data was obtained from the experiment. If the concentration of A is double while the concentration of B remains constant, the reaction rate increases fourfold. If the concentration of A and B are triple, the reaction rate increases 27-fold. The dot format in a colorless or odorless is easily identified. If the value of the reaction rate constant is 4 times 10 range -5 determine the reaction rate when the concentration of A is 0.2 m and the concentration of B is 0.1 m. Question number 11. At room temperature around 25 degrees Celsius in an open laboratory without humidity control, the following reaction was carried out. 2A plus B produces 3C. The following data was obtained from the experiment. If the concentration of A is double while the concentration of B remains constant, the reaction rate increases fourfold. If the concentration of A and B are triple, the reaction rate increases 27-fold. The dot format in a colorless or odorless is easily identified. If the value of the reaction rate constant is 4 times 10 range -5 determine the reaction rate when the concentration of A is 0.2 m and the concentration of B is 0.1 m. Question number 11. At room temperature around 25 degrees Celsius in an open laboratory without humidity control, the following reaction was carried out. 2A plus B produces 3C. The following data was obtained from the experiment. If the concentration of A is double while the concentration of B remains constant, the reaction rate increases fourfold. If the concentration of A and B are triple, the reaction rate increases 27-fold. The dot format in a colorless or odorless is easily identified. If the value of the reaction rate constant is 4 times 10 range -5 determine the reaction rate when the concentration of A is 0.2 m and the concentration of B is 0.1 m. Question number 11. At room temperature around 25 degrees Celsius in an open laboratory without humidity control, the following reaction was carried out. 2A plus B produces 3C. The following data was obtained from the experiment. If the concentration of A is double while the concentration of B remains constant, the reaction rate increases fourfold. If the concentration of A and B are triple, the reaction rate increases 27-fold. The dot format in a colorless or odorless is easily identified. If the value of the reaction rate constant is 4 times 10 range -5 determine the reaction rate when the concentration of A is 0.2 m and the concentration of B is 0.1 m. Question number 11. At room temperature around 25 degrees Celsius in an open laboratory without humidity control, the following reaction was carried out. 2A plus B produces 3C. The following data was obtained from the experiment. If the concentration of A is double while the concentration of B remains constant, the reaction rate increases fourfold. If the concentration of A and B are triple, the reaction rate increases 27 form. The product format is colorless, odorless, is easily oxidized. If the value of the reaction rate constant is 4 times 10 rain minus 5, determine the reaction rate when the concentration of A is 0.2 m and the concentration of B is 0.1 m. First time, given reaction to A plus B produces 3C. Concentration A action equals to concentration A. Concentration B action equals concentration B. Phi action equals 4 phi. And concentration A action equals 3 concentration A. Concentration B action equals 3 concentration B. And phi action equals 27 phi. And K equals 4 times 10 rain minus 5 at phi equals blank 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 produce concentration A equals 0.2 m and concentration B equals 0.1 molar. Answer: the formula phi equals K concentration A ring X times concentration B ring Y. So first time phi action equals K times concentration A action X times concentration B action Y. For phi equals K concentration 2A ring X concentration B ring Y. For phi equals K 2 ring X concentration A ring X concentration B ring Y. So 4 equals 2 ring X produce 2 ring 2 equals 2 ring X. So X equals 2. Next, phi action equals K concentration A action X concentration B action Y. 27 phi equals K concentration 3A ring X concentration 3B ring Y. 27 equals 3 ring X times 3 ring Y. 27 equals 3 ring X plus Y because 3 ring 3 equals 27. So 3 ring 3 equals 3 x plus y. 3 equals x plus y and 3 equals 2 plus y. So y equals 1. Next, phi equals K concentration A ring 2 concentration B. Phi equals 4 times 10 ring minus 5 times 0.2 ring 2 times 0.1 equals 4 times 10 ring minus 5 times 4 times 10 ring minus 2 and times 10 ring minus 1 equals 16 times 10 ring minus 8 equals. Next, phi equals K concentration A ring 2 concentration B. Phi equals 4 times 10 ring minus 5 times 0.2 ring 2 times 0.1 equals 4 times 10 ring 6 times 10 ring minus 7 per second. 6 times 10 ring minus 7 per 12. Question number 12. Consider the following reaction for pH3 produce P4 plus 6H2. For the right equation minus D concentration pH3 per dt equals K concentration pH3 in experiment in a 4-liter container. 0.0024 moles of H2 gas are formed per second. Concentration pH3 equals 0.2 molar. Then compare the reaction rate constant. And given R equals 8.14 joule per mole times K and 1 liter of gas at STP equals 0.0446 mole. And given R equals 8.14 joule per mole. Okay, let's solve the question. Discussion. Given pH3 produce P4 plus 6H2. Rate equation equals minus D concentration pH3 per dt equals K concentration pH3. and the concentration H2 equals 0.0024 mole per 4 liter. Asks the rate of formation of H2 blank blank blank. Okay, let's solve the question. Discussion given pH3 produce P4 plus 6H2 with equation equals minus the concentration pH3 per dt equals K concentration pH3 and the concentration H2 equals 0.0024 mole per 4 liter. Asks the rate of formation of H2 blank blank blank. Okay, let's solve the question. Discussion given pH3 produce P4 plus 6H2 with equation equals minus the concentration pH3 per dt equals K concentration pH3 and the concentration H2 equals 0.0024 mole per 4 liter. Asks the rate of formation of H2 blank blank blank. Okay, let's solve the question. Discussion given answer. The rate of formation of H2 equals plus the concentration H2 per dt. So 0.0024 per 4 liter per dt equals 0.0006. Because from the reaction equation for pH3 produce P4 plus 6H2, the ratio of the reaction rate is 1 per 4 times the concentration pH3 per dt equals 1 per 6 times the concentration pH2 per dt and K concentration pH3 equals 4 per 6 times 0.0006 molar per second and K equals 0.000396 or K equals 3.96 times 10 raised minus 4 per second and K equals 0.000396 or K equals 3.96 times 10 raised. So the ratio of the reaction rate is K equals 3.96 times 10 raised minus 4 per second. So the ratio of the reaction rate is K equals 3.96 times 10 raised minus 4 per second. So the ratio of the reaction rate is K equals 3.96 times 10 raised minus 4 per second. So the ratio of the reaction rate is K equals 3.96 times 10. Let's solve the discussion. Given the composition reaction of SO3 compounds equals SO3 plus SO2 plus O2. Ask comparison of rates of change in concentration. Solution 2O3 produce S. Discussion. Given the composition reaction of SO3 compounds equals SO3 plus SO2 plus O2. Ask comparison of rates of change in concentration. Solution: 2SO3 produce SO2 plus O2 and minus 1 per 3 equals D concentration SO3 per dt times 1 per 2 times D concentration SO2 per dt times D concentration O2 per dt, meaning reduction rate concentration SO3 equals 2 times formation rate concentration SO2. Formation rate concentration SO2 equals 2 times formation rate concentration O2. Rate comparison SO3 comparison SO2 comparison O2 equals 2 comparison 1. So the ratio of the rate of change in concentration of SO3 comparison SO2 and comparison O2 is 2 comparison 1. Solution: 2SO3 produce SO2 plus O2 and minus 1 per 3 equals D concentration SO3 per dt times 1 per 2 times D concentration SO2 per dt times D concentration O2 per dt, meaning reduction rate concentration SO3 equals 2 times formation rate concentration SO2. Formation rate concentration SO2 equals 2 times formation rate concentration O2. Rate comparison SO3 comparison SO2 comparison O2 equals 2 comparison 1. So the ratio of the rate of change in concentration of SO3 comparison SO2 and comparison O2 is 2 comparison 1. Solution: 2SO3 produce SO2 plus O2 and minus 1 per 3 equals D concentration SO3 per dt times 1 per 2 times D concentration SO2 per dt times D concentration O2 per dt, meaning reduction rate concentration SO3 equals 2 times formation rate concentration SO2. Formation rate concentration SO2 equals 2 times formation rate. Let's start with question number 14. Question number 14, reaction 2A plus B product with rate V equals 0.2 concentration A range 2 concentration B. Currently, concentration A equals 1.10 mole per liter. Concentration B equals 1.20 mole per liter. Product V equals 40 times 10 raised minus 4 moles per liter second. And V target equals 1.6 times 10 raised minus 3 moles per liter second. In order for the rate to reach the target, the concentration changes are made. Strategy A. Concentration A is increased by 2 times product concentration A equals 0.20 mole per liter. Strategy B. Concentration B adjusted. From this data, design the concentration value concentration B that must be used so that strategy A successfully achieve the target reaction rate. Next, let's solve the question for number 14. Discussion: given concentration A equals 0.10 product 0.20 mole per liter. Concentration B equals 0.20 mole per liter. V target equals 1.6 times 10 raised minus 3 mole per liter second. Asks what concentration B is required. And solution for question: V equals 0.2 times concentration A range 2 concentration B. Target substitution 1.6 times 10 raised minus 3 equals 0.2 times 0.20 raised 2 times concentration B equals 0.008 times concentration B. So concentration B equals 1.6 times 10 rain minus 3 per 0.008 equals 0.20 mole per liter. So concentration B remains, only concentration A is increased, then we get the value concentration B is equals 0.20 mole per liter. Okay, next, let's start with question number 15. In a chemistry lab, a student put 8 grams of substance A or A1A equals 65 into a test tube containing 200 milliliter of 2 molar Hassel solution. After the reaction took place for 2 minutes and 1.5 gram of substance A remained. Analyze the rate of reduction of substance A that occurred. Let's solve the question for number 15. Discussion. Given initial mass of substance A equals 8 gram, remaining mass of substance A equals 1.5 grams. Mr. Substance A equals 65 and reaction time equals 2 minutes. Ask the rate of reduction of substance A in mole or min bang bang bang. Solution and answer. Mass that reacts equals 1.5 gram minus 8 gram equals minus 6.5 gram, and A equals gram per AR equals minus 6.5 per 65 equals minus 0.1 mole. And concentration A equals N per V equals minus 0.1 mole per 0.2 liter equals 0.5 molar. And delta T equals 2 minutes equals 2 times 60 seconds equals 120 seconds. So VA equals delta A per delta T equals minus 0.5 molar per 120 seconds equals 4.2 times 10 rain minus 3 molar per second. Thank you for the listening. Let's move to Nurul for the final set of questions. Thank you.
Hello everyone, I'm Nurul and I'll be presenting the last 5 questions which are number 16 to 20. Let's begin with question number 16. At 273 degrees Celsius, bromine gas reacts with nitrogen monoxide gas. The reaction is 2NO aqueous plus Br2 gas product to NOBr gas. Based on the reaction experimental that was obtained. The given trial 1 concentration of NO is 0.02 molar, concentration of Br2 is 0.05 molar, reaction rate is 0.48 molar per second, temperature is 87 degrees Celsius. Trial 2 concentration of Br2 increases to 0.10 molar, reaction rate becomes 0.96. Trial 3 concentration of NO increases to 0.04 molar, reaction rate becomes 0.84. The ask determine the order of the reaction for NO and Br2. Calculate the reaction rate if concentration NO equal 0.01 molar and concentration Br2 equals 0.05 molar. The answer. Step 1. Order of Br2. In trial on 1 and 2, NO is constant. Br2 concentration doubles from 0.05 to 0.10. Reaction rate also doubles from 0.48 to 0.96, so the order of Br2 is 1. Step 2. Order of NO. In trial 2 and 3, Br2 is constant. NO doubles from 0.02 to 0.04. Reaction rate increases 4 times from 0.96 to 3.84. So the order of NO is 2. Step 3. Calculate new rate. We use the rate law. Rate equals
K times concentration of NO squared times concentration of Br2 from triangle 0.4x equal K times 0.02 squared times 0.05. So K equals 24,000. Then rate equal 24,000 times 0.01 squared times 0.05, 0.12 molar per second. Now, I explain question number 17. In an experiment, gas A and gas B react to form gas C and gas D. Direction is 2A plus 2B from 4C and 3D. Gas C is isothermic and produces color. The given trial 1, A 0.2, B 0.2, temperature 60 degrees Celsius, rate 4.8. Trial 2, B 0.4, rate 4.8. Trial 3, A 0.4, rate 9.6. We compare trial 1 and 2. A is constant, B changes, rate stays the same, so the order of B is 0. We compare trial 2 and there, B is constant, A double, and the rate also double, so the order of A is 1. Total reaction order is 1. Now, moving on to question 18. Fish order reaction A from B, time to form 0.8 mole of B. Compound A react to from B. The reaction is first order with a rate constant K equals 0.04 per minute. Initial amount of A is 1 mole. To ask how long does it take to produce 0.8 mole of B? The answer, since B equals 0.8 mole, then A that remains is 0.2 mole. Use the first order equation. Then concentration A0 over A equal K times T. Then 1 over 0.2 equals 0.04 times T. So in 5, 0.04 T. Then T equal 15 minutes. Next, we have question 19. Half-life of NiCl4. NiCl4 decomposes by first order kinetic. Start with 0.625 grams. After 1 hour, only 0.025 grams remain. The ask determine the half-life in minutes. The answer, we use the formula. Then concentration A0 over A equal K times T. Then 0.625 over 0.025 equal K times 60. Then use half-life equal 0.69 the over K. So half-life is 30 minutes. And finally, question 20. Please order the say concentration after 10 seconds. Reaction A to product follow first order kinetic. K equals 0.2 the 1 per second. Initial concentration is 0.8 molar. Find the concentration of A after the second. And finally, question 20. Know that K equals 0.2 the 1 per second. Concentration of A now is 0.80 molar. T equals 10 seconds. The ask to find the concentration of A after 10 seconds. The answer or solution, we use the first order right-law equation. A at time T equal A now, time A to the power of minus KT. Substitute the values into the formula. A at time T equals 0.80 times A to the power of negative 0.231 times 10. This gives us A at time T equals 0.80 times A to the power of minus 2.31. Now we approximate a to the power of negative 2.01. A to the power of minus 2.31 is approximately 0.099. Then we multiply 0.80 times 0.099 equal approximately 0.079 molar.